Hey everyone, now we will discuss the isotope analysis for carbon dioxide. The chemical composition of atmospheric carbon dioxide provides evidence that the increase in carbon dioxide is primarily due to fossil fuel combustion. Carbon is naturally present in the atmosphere, oceans, plants, and animals as part of the carbon cycle. Plants absorb CO2 through photosynthesis process, and animals and plants release CO2 through respiration, that is breathing. This cycle helps maintain a balance of carbon in the atmosphere. But fossil fuels such as coal, oil, and natural gas are formed from the remains of ancient plants and animals that lived millions of years ago. When we burn these fossil fuels for energy, such as in power plants, our vehicles, or for heating in our homes, carbon that was trapped for millions of years is released as CO2 into the atmosphere. Hope you remember some parts of your school chemistry lessons on isotopes. Simply, an isotope is a type of atom that has the same number of protons as other atoms of the same element, in our case carbon, but has a different number of neutrons. This means that isotopes of an element have the same chemical properties, but they can have different masses. An isotopic signature refers to the specific combination of isotopes present in a sample of a substance. Since different sources or processes can create different combinations of isotopes, scientists can use isotopic signatures to identify where a substance came from or how it was formed. It's like a unique fingerprint that helps scientists understand the origin and history of materials. Carbon atoms have different isotopes, which are variations of the element with different number of neutrons. Fossil fuels have a distinct isotopic signature because they come from ancient carbon sources. The carbon in fossil fuels has a lower proportion of the isotope carbon-14 compared to carbon-12. As we burn fossil fuels, the carbon dioxide released into the atmosphere carries the isotopic signature of fossil fuels. By measuring the carbon isotopes in atmospheric CO2, scientists can determine if the increase in CO2 is primarily from fossil fuel combustion or from natural sources. Scientists collect air samples and measure the ratio of carbon-14 to carbon-12 in the atmospheric CO2. Over time, they have observed a decrease in the carbon-14 ratio in atmospheric CO2, indicating an increase in carbon from fossil fuels, which have a lower carbon-14 ratio. Multiple independent measurements from various locations around the world have shown a consistent decrease in the carbon-14 ratio, providing strong evidence that the increase in atmospheric CO2 is primarily due to the burning of fossil fuels. So, in summary, the chemical composition of atmospheric carbon dioxide, particularly the isotopic signature, indicates that the increase in CO2 is largely attributed to the combustion of fossil fuels. Now we will understand another isotope analysis technique which involves air bubbles trapped in glacial ice. By examining air bubbles trapped in glacial ice, scientists can measure the chemical composition of atmospheric carbon dioxide back through time. Scientists drill deep into glaciers or ice sheets to retrieve long cylindrical samples called ice cores. These ice cores contain layers of ice that have accumulated over thousands of, or in some cases even hundreds of thousands of years. This process is called ice core sampling. As snow falls and compacts over time, it forms layers of ice. During this process, tiny air bubbles from the atmosphere become trapped within the ice layers. These air bubbles are preserved as the ice solidifies. Scientists carefully extract and analyze the ice cores in labs. They focus on the air bubbles contained within the ice. To measure the chemical composition of atmospheric gases, scientists melt the ice cores and extract the trapped air bubbles. By doing so, they can collect a sample of ancient air that was trapped in the ice at the time it formed. The extracted air sample is then analyzed using various techniques. One common method is to separate the different gases within the sample and measure their concentrations. For carbon dioxide, scientists use instruments that can precisely determine its abundance. By analyzing the chemical composition of CO2 in air bubbles at different depths in the ice core, scientists can reconstruct the historical concentrations of CO2 in the Earth's atmosphere over thousands of years. The reconstructed CO2 concentrations from ice cores provide valuable information about past climate conditions. By comparing CO2 levels with other climate data such as temperature records or other proxies, scientists can understand the relationship between CO2 and climate and study long-term climate variations. So the analysis of air bubbles trapped in glacial ice allows scientists to measure the chemical composition of atmospheric CO2 back through time. By extracting ancient air samples from ice cores and analyzing their CO2 concentrations, researchers gain insights into past atmospheric CO2 levels and their role in shaping Earth's climate over thousands of years.